Okay, the first technical presentation is about data capture methods. It covers a range of things, but it's heavily biased towards geometric reverse engineering. The presentation will be geometric scanning techniques, volumetric scanning methods, and also pressure mapping. Geometric scanning techniques are often referred to as reverse engineering or digitizing. And what they allow us to do is take an existing object and to capture the geometry from it in an electronic form. And that can then be used in design and manufacturing operations. To try and keep the presentation short, we'll now be referring to reverse engineering or RE rather than geometric scanning techniques. It's too long. The reasons for using reverse engineering are things like we have an old product where there's no CAD data. We might have handcrafted products or works of art we want to scan. Often products are modified in production without anyone recording the changes. You know what happens, you get a part, you're trying to send it to work, someone takes a file to it, modifies the thing, but nobody bothers to actually make a record anywhere. And then we're in trouble later on when the thing needs replacing. There is a little bit of copying of existing products that don't belong to you and borrowing the data. And yes, there is an issue here between breaking the law and not breaking the law. And this is a fairly fine line. We won't go into too much detail about that. I think it's sufficient to say that the Chinese market was the biggest market for Renishaw cyclone machines in the first year. They sold 6, didn't sell any more. So we can only assume that also the machines for copying are also being copied as well. So another thing you might want to do is to capture natural products as well. So actually the human body, or it could be things, a piece of slate you pick up, or a garden leaf, or something you want to use as a motif in your products. And also reverse engineering is now being used for inspection, where you have some complex curved components. Why does it fit into reverse engineering? Why bother with, why does reverse engineering fit into customized products? Where is the link? Well, one of the major things you'll see today is the use of custom fitting products. Ones that actually take data from the human body and are actually matched to that geometry, for example, a prosthetic limb. We also might want to capture data on natural products to generate a new design, and we'll show an example case study later in the presentation. But there's a tile company in Spain. If you take a bitmap, will generate a raised image on the tile bespoke for you, just by scanning it. And also there's the geometry of existing products to generate bespoke variants. And if you have added a body kit to your Ford Escort, you'll know that that's generated probably by 2 guys in a garage who've captured the data, not necessarily with reverse engineering techniques, but have actually had to reverse engineer the information from an existing car. First question, is anybody here actually using reverse engineering or customization? Let's have a look at reverse engineering first. So 5, 6 about in reverse engineering. How many involved in customization? Six, 7. So it's actually a similar number, but not straight the same hands. So, okay, there's obviously different ways of doing customization. You don't necessarily need to use reverse engineered data. A little bit of history, just to put us in the context. Reverse engineering is not new. Before the Industrial Revolution, all parts were effectively reverse engineered. They were duplicated manually and copied by eye. And often if a product became too worn, if the cart wheel fell off your cart, you'd take it to a wheelwright and he would copy that existing, or the wheel that was okay. So you've got 2 wheels on your car. There is two primary drivers you can look at which have helped develop reverse engineering science. And one is war and one is art. Quite opposed to each other in a way. An example here is that if you want to try and match the military capability of your foes, you're not going to be asking whether you can about copyright. You know, so you're going to try and copy their Gatling gun or copy their armaments as quickly as possible. And here's a slightly less dangerous reverse engineering job, which is the jerry can, which was copied by the Allies from a very nice German design. Also in art, any of you guys artists? A couple of people. You know, it's obviously difficult sometimes if you want to capture information quickly and then go into the comfort of your own home and draw a picture. We have now photographs, but in the past we didn't have those things. And Albrecht Dürer, back in the 15th century, effectively came up with a way of using projected light to copy objects. And of course that was the first optical reverse engineering method, apart from your eyes, of course. Things like pantographs, this is the Chevington reducing machine, which allowed people like the British Museum to copy existing artifacts and sell them in their museum shop of the 1800s. Just a mechanical linkage. Copy milling, then the development, when we wanted to manufacture larger numbers, we can use the existing product as a pattern, which we simply drive a stylus around and then mill a block at the same time to the shape of that product. It's not commonly used now, it's gone out of favour. And the reason behind this change is because we have CAD now. People expect to see data in a digital form. And one of the challenges for the industry is to come up with a way of reverse engineering into a digital domain. Anyone got an idea what this is? I'm reliably told by Wikipedia it's the space shuttles on the landing pad at Houston or something. I have no idea. I mean, it's pretty hard to tell. But that is a set of cloud points taken from obviously a fairly large format reverse engineering system. This is a little bit clearer here. This is obviously a human skull. We collect the data of an object as three-dimensional coordinates, and then we have to process that data in order to use it. Because there's not an awful lot you can do with cloud point data. It's simply a series of coordinates. And the post-processing can be quite involved. And we'll go into that in more detail at the end of the presentation, toward the end of the presentation today. There are two primary options with reverse engineering. One is contact and one is non-contact. I'll quickly go through some of the techniques. The good news is we have people here demonstrating equipment at lunchtime. So as well as seeing the pictures, you can actually see equipment being used and understand some of the difficulties and some of the opportunities with the equipment. I've mentioned about taking dimensions in your micrometer. Sometimes if that's all you have, that's fine. And for some objects, you don't need anything more sophisticated really than a ruler to reverse engineer it. We've got hard probing, touch trigger probing, scanning, and also in non-contact we can eyeball it and roughly work out how big it is, or we can use more sophisticated techniques like laser point scanning, laser strip scanning, structured light and photogrammetry. This does not cover all of the reverse engineering techniques, but covers the ones generally used in product development. Okay, hard probes. I refer to these as dumb probes. They're a piece of steel with a tip on them. Maybe it has a ruby stylus on, but usually it just comes to a point. And it's placed in contact with the object, and you press a button to collect that particular coordinate. They are not so frequently seen now. These got the old coordinate